This is the top of page 4 of the study guide for Algebra, benchmark 2. And so let's take a look at these first problems here. Question number 50 on the test is going to be dealing with exponent rules. So it'll look something like this, one of these types of problems where you have a fraction and you'll have to reduce it, but you'll have some exponents on variables. And so what you'll need to do is treat these as two separate problems. You've got the coefficient, so we've got the 3, and then we've got underneath a 15. So you'll treat that as one part of the problem, and then I'll extend the fraction bar to leave some room for the x's. I got x to the 4th and x to the 8th power as well. And so what I'm going to end up doing is reducing the 3 and the 15. Common mistake is people want to subtract these numbers, but that's not what we do. We take out a common factor. So 3 is the common factor I'm taking out. And so what's left? Well, we go ahead and write our answer here. I've got the 3 divided by 3 makes 1. 15 divided by 3 makes 5. Over here I'll cancel out some x's, but think about where the x's are left. And so these 4 x's are going to take away 4 x's from the bottom of the fraction. And so I'm left with 4 x's on the bottom. So it's going to be 1 over 5x to the 4th power is what I'm looking at. So there's one answer. Let's take a look at the next. Again, treat these as two separate parts here. So I'm going to take this 6 and I'm going to divide it by 6 because 6 goes into 6 and 12. So divide this 12 by 6 as well. And so what's left over when I do that division? Well, 6 divided by 6 makes 1. 12 divided by 6 makes 2. Now let's cancel out some x's. So let's think about where those x's are left. These 5 x's will take away 5 x's from the top, leaving me with 10 x's on top of the fraction. And so I have 1x to the 10th over 2. So you'll probably see the answer is just x to the 10th over 2. Now the next one, very similar. Just take out the common factors. So you look at the 20 and the 15. What goes into those numbers? 5 goes into those numbers. So you're reducing that fraction by taking out a common factor of 5 in this case. And so let's go ahead and rewrite that part. 20 divided by 5 gives me 4. 15 divided by 5 gives me 3. And so now we need to think about how many x's are left in the problem. Well, these 8 x's will cancel out 8 x's from the top, leaving me with 1x on top. So there it is. We've got just 4x over 3. Well, taking a look at the next one, we've got a common factor again we can take out. See, 18 can be divided by 9, and so can 9. We can take out a 9 from the top and the bottom. And so let's write what's left over here. We've got 18 divided by 9 gives me 2. 9 divided by 9 gives me 1. Now we move on to the x's, and I take away 1x from the bottom, and I take away 1x from the top, leaving me with 1x on top. So there will be my answer, just 2x over 1. But you might see the answer is just 2x. Well, in this next one, we need to take out the common factor again. 4 goes into both 4 and 12, so we'll take out a 4 on the top and bottom. Let's see what's left over. So on the top, 4 divided by 4 makes 1. 12 divided by 4 gives me 3. So we go ahead and take out the common x's now. These 9 x's will take away 9 x's from the bottom. And so how many x's are left? And where are they at? Well, there's 1 x left, and it's on the bottom of the fraction. So it's 1 over 3x. Looking at the next few problems, these are asking us to add or subtract polynomials. It looks like we've got 3 problems, 51, 52, and 53 on that. And so 2 of them are going to be just like this, where you're just adding a polynomial, and then one will probably be a subtraction of a polynomial. So when we're adding, you just line up the terms that you can combine with. So the 5x squared goes underneath the 3x squared. The negative 3x goes underneath that positive 2x. The negative 8 underneath the negative 1. And you're just adding those numbers together. And so when you do that, same sign you add. So 3x squareds and 5x squareds makes 8x squareds. Don't change the exponent on the addition problems, only multiplication, because that's what exponents represent, is repeated multiplication. 2x minus 3x gives me the negative 1x, and the negative 1 minus 8 makes negative 9. Same sign, so I added those numbers together. You'd probably see the answer is 8x squared minus x minus 9 on that. I usually don't write the 1 as the coefficient. Well, when we've got a subtraction problem, change it to addition. So all of these signs are going to switch. That becomes a negative, this becomes a positive, this becomes a negative. And then just take those numbers and write them underneath, the ones you can combine with. So negative x squared, a positive 9x, and a negative 8. And you're adding that together. So when we have the same sign, you add, opposite sign, subtract. So here we're going to subtract. We've got a negative, actually a positive 1x squared, or just x squared. Here we subtract because they're opposite signs, positive 5x. Here we add because they're the same sign, negative 17. There's our answer. So same thing over here, add the opposite because it's a subtraction problem. So make sure you do that on your problem that you'll see. Now once we've changed it to addition, we can go ahead and just take any terms and move them underneath. So I can take these 4x squareds and put them underneath the negative 3x squared. Take this positive 2, put it underneath that positive 1. Add that stuff together. So when we add this, opposite sign subtract, so we're just left with an x squared. Here we can't combine that negative 2x with anything. And here we have to add those two numbers, the 1 and the 2. Well, here's a problem that asks us to add. It says the sum of the two binomials is this. Oh, okay, this is the sum, so maybe it's a subtraction problem. So if one of the binomials, one binomial is this, what is the other? What is the other? Well, the two binomials sum to make this. That means that we don't know one of them. So it's kind of like this. It's kind of like saying a question mark, it's one of the binomials, plus the 4x squared plus 2x minus 1 equals the 3x squared plus 4x minus 7. So really this is a subtraction problem. We've got to take this away from this. So what I'll do here is I'm going to go ahead and take this away. So this is my binomial or trinomial here. I'm going to take this away from this. So I'm going to switch all these signs. So I'm going to write down negative 4x to the second. I've got a negative 2x and a positive 1. So I'm taking this away from the one that I had. And I just did opposite signs there because I added the opposite. So when I do that, my answer is going to be a negative x squared, a positive 2x, and a negative 6. Because I just subtracted because they're all opposite in sign. Well, looking at the next one, it says multiply polynomials. So 54, 55, 56 are all on this. So the length of a rectangle is 2x minus 3. Let's draw a picture. There's my rectangle. 2x minus 3, that's the length. The width, 5x. Find the area. Well, area is just base times by height. Or length times by width, same thing. So I'm just multiplying. So it's just a 5x times by 2x minus 3. So when I do that, I use that distributive property. Multiply the 5x over that difference. Let's see what we get here. So remember, it's 5 times 2 makes 10. X times x makes x squared. So notice that you get x squared when we're multiplying. Not when we add, but when we multiply. 5x times by the negative 3 gives me a negative 15x. This is an area problem. I'll just stick some units on there. Units squared is what we would end up having there. Well, here is a FOIL method problem. We're going to do the first, the outer, the inner, and the last because it's a binomial multiplied by a binomial. So first one here, we have x, and x gives me an x squared. Outside terms are x, and negative 4 makes a negative 4x. Then we move on to the inside. 2 and x make a positive 2x. And then the last terms, 2 and negative 4 make a negative 8. And so we can collect a couple terms. These two terms right here have the same variable raised to the same power. So I just bring down my x squared, minus 2x, and then a minus 8. And there's my answer. So another FOIL problem to try here. We've got a x times x. Those are my first terms. so that makes x squared. And I move on to my outside terms, x and 7, so plus the outer terms, so that makes a 7x. Then I'll move on to my inside terms, so that's the 8 and the x, so plus the inner, and that makes an 8x. And then my last terms, 8 and 7, so plus my last, and that makes a 56 is what I get when I add or multiply the 8 and 7. So I can go ahead and collect the outer and inner terms in this case. So I'm left with that x squared plus 15x plus 56. So here's a monomial times by a polynomial, in this case a trinomial. So you're just multiplying using that distributive property, counting up how many x's we have being multiplied together. So 3x to the 4th power is what we get for the first one. And then negative 12x to the 3rd. Notice how I change the exponents when I multiply. X times x squared makes 3x's. 3 times 9 gives me 27, but I just got to bring down that x to the 2nd. There's my answer. Same thing on this one. Distribute. Watch the signs, though. Negative 2n to the 3rd. And then negative times a negative makes a positive 10n squared. And then the last one's here. Negative 2 times 3 makes a negative 6n. There's the answer. Well, check out the next part for the bottom of page 4.